What's going on, guys? Today I am going to be talking to you guys about a mathematical concept called the Pythagorean Theorem. So this is a tutorial on how to use the Pythagorean Theorem, kind of what it is, what it's used for, and how to use it in special situations. So, who developed this? Well, a Greek mathematician named Pythagoras lived in about 500 BC, about the time. So he is famous for developing this. And what it's used for is finding the unknown sides of right triangles. Now, it can only be used for right triangles. And recall, what is a right triangle? A right triangle is a triangle in which there is one right angle in the triangle. So keep that in mind, and remember, this can only be used for right triangles. So what is this Pythagorean theorem? What does it say? Well, basically what it's saying is that the square of the hypotenuse, which is the longest side, so the hypotenuse squared is equal to the sums of the squares of the legs. Now that might not make a lot of sense to you right now. That's fine, but let's dive into it. So the Pythagorean theorem is most commonly written as or remembered as a squared plus b squared is equal to c squared. So what does this mean? So you have a right triangle. Remember, 90 degrees. We have to know it's a right triangle. We have to be given that this measure is 90 degrees, or else we cannot use the Pythagorean theorem. So, we have side A, side B, and side C. Sides A and B are the legs, and side C is the hypotenuse. So basically what this is saying is that A squared, so the length of this side squared, so remember, since it's squared, we're multiplying it times itself. So A, the side A squared, plus this side, B, the other leg, squared, is equal to C squared. And then, once we simplify it, you will be able to find the lengths. If you have the lengths of at least two sides, if you have the lengths of any two sides, whether they're the two legs or a leg and the hypotenuse, you can find the unknown side, which I'll show you using simple algebra in a minute. So, let's start with one example. So, question number 1. If two legs of a right triangle measure 5 inches and 7 inches, what is the length of the third side, or the hypotenuse? So, we're given our two legs and we have to find the hypotenuse. So, let's go ahead and solve this. Step number 1. Analyze what you are given in the problem. So remember, we have the lengths of two legs, which are 5 and 7 inches. So, we know that side A is 7 inches, or is 5 inches, and side B is 7 inches. So, it might be easier to visualize it first, so we can draw out our triangle real quick. So we got 5 and 7. So this is the side that we have to find. Well, the best way to do it is to simply plug in all of your known variables into the formula, replacing the unknown variables. So if a squared plus b squared equals c squared, we know we can plug. We know what a and b are, so we can plug that in. So a is 5, so we have 5 squared. We know b is 7, so 5 squared plus 7 squared equals c squared. So let's simplify this a little bit. We know that 5 squared is 25 because we multiply it by itself. So we know that 5 times 5 is 25, plus the square of 7 is 49. So 25 plus 49 gives us what c squared is. So now we have to add that in our head. So we know that 50 plus 25 is 75, minus 1 is 74. So 74 equals c squared. However, we're not done yet. If 74 equals c squared, what is c? We don't want to know c squared, we want to know c. So in order to get c, if we just want c, we have to find the square root of 74. Remember, the square root of a number is the number you would multiply by itself to get that number. So, the square root of 74 is what would give us our c. So, that's not really something I feel like figuring out right now, so let me go plug it into a calculator and figure it out. Thus, after we find the square root of 74, which is approximately 8.6, we have our answer. So now if we can find that third side of the triangle if we have two side lengths. So we know that this side would be 5, we know this side would be 7, and now that we were able to figure that out, we know this side would be approximately 8.6. So that is how you would use the Pythagorean theorem to find the unknown length of a triangle. Let's try another example. Alrighty guys, example 2 is find the value of b. So, this is a little different. This time, we're not aiming to find the hypotenuse because we already have that. We need to find b. So, this may seem a little trickier, which it is, but we still set the equation up the same way. The golden rule of algebra, well, there are many golden rules of algebra, but one of them is whenever you have to solve for something and you know there's a formula you use, you plug in those known variables. It will make solving a lot easier. So, remember, let's recall the Pythagorean theorem. A squared plus b squared equals c squared. We have a. A is 15, so we know 15 squared plus b squared, we still don't know what that is, equals 22 squared. So, let's plug that in. If your teacher allows you to use a calculator, of course, go ahead. But if your teacher does not allow you to use a calculator, don't do that. I'm going to use a calculator to save time. So, 15 squared, I should know this is 225. So, 225 plus b squared equals. Now, what's 22 squared? So, solve for 22 squared, multiply 22 times 22. We get 484. Okay, now, this goes back to simple algebra. What are we trying to solve for? We're trying to solve for b. So, we have to get b by itself. And in order to do that, we would have to subtract 225. So, let's subtract 225 from 84. So, I'm just doing this on my calculator. So, then we get 259. So, we know b squared equals 259. That looks like it says 250, so I will add a 9. Okay, we have what b squared is, but what's b? I want to know what b is. I don't want to know b squared. So, how would we solve that? Well, just like we did in the last problem, it's finding the square root. Because remember, if we have squared, the opposite of squaring something is finding the square root of it. So, recall how we write that would be like this. So, I'm going to plug that into my calculator, and the square root of 259 gives us approximately 16.1. So, I am going to write approximately 16.1. So, now we know b is approximately equal to 16.1. So, I hope that was helpful to you. I'm going to wrap up that video. I hope that was helpful for you guys in learning the Pythagorean theorem. So remember, you can use any right triangle. The Pythagorean theorem works with any triangle as long as it's right. Remember, we have to know that it's a right angle and using simple algebra to solve this. So, if you guys want to be able to practice this on your own to study, I will put links to practice worksheets in the description. Of course, you could probably just Google them and find them yourself. But yes, guys, that is the Pythagorean theorem. I hope this tutorial cleared up any confusion on how to use this. So, I will see you in my next video. Peace for now.